Yo, how you doing? My name is Hamish, but a lot of people like to call me 25 Bacteria. If you FaceTime my channel, before you do anything, make sure you click the subscription button, share with a lot of people, and let's get started. So we have a question here, question number 4. So you have a number line. The number line, look, it's half from -2 to negative infinity. Because look, it's half from -2. You go all the way to the left, means negative infinity. This is our line. Here there's nothing here, there's no element. Here you have a 3 including, see, whenever it's solid down means including, means this is including here. Because it's solid to the right. So in other way, this is same as say x is less than -2, or x is greater or equal to 3. Why greater or equal? Because it's including. Here it's excluding, that you just put only one, and is less. But excluding what? Excluding -2. But here x, excuse me, is greater or equal to 3 because including. Now we come here now to say or less or greater by including. So now they come here to say which of the following does not describe the sketch above, means which, in other words, which one is not true. It does not describe the sketch above. So the right other way around. Now we go. Okay, we start from -2. Yes, from -2. See. Okay, whenever you write your number line or whenever you write your interval notation, always start from the left. So from the left, you will know this start from the left is negative infinity. But when infinity means you don't know which exactly point, so you exclude. That's what I say here. This is exclude all negative infinity all the way to 2. But 2 also is excluding. 2 also is excluding. So we say negative infinity excluding all the way to 2. Negative also is excluding. Also unite means this or from 3, but 3 is including. So from 3, always start from the left, go to the right. So we start from 3 all the way, but it's including. So when it's including, write this, excluding, write this. All the way, we don't know where we're gonna stop. So means it's positive infinity. So you don't know where you're gonna stop means you don't know exactly the point. That's why they exclude. So this is true. Now we go for the second one. So this is the way of writing interval notation. So now we want to see the next one. The next one. So this is true. The next one. So okay. So let me give us this. This is true also. This is a way of writing our representing our data in a set builder notation. So let's actually look. Let's say exactly what I wrote here. X is less -2 and x excluding. Yes, it's true, it's excluding. Or x is equal or bigger than 3. It's true because either is less than -2 but it's excluding, and also or not ended. So that's what I'm saying, or, because when you say ended means they have something common. They don't have anything common. That's why we use or. So less than -2 or x greater than 3. So this is true. And you say x are element of real number, means these are numbers. You know what I'm saying? You know, real number means like any number, 1, 2, 3. You know what I'm saying? But not like complex number, which you don't do for now in your level. So this is true also. So this is true. Now we go for the third one. So this is not true. You know what I'm saying? Because when you say okay, when you say ended means, look, for example, if somebody give me this, so let's say for example, let's say x is between -1 and 2, let's say. So -1 means excluding, it's going to be like this, and 2 is let's say including. So let's say this is set A. This is for set A, and then you have set B, for example. B, let's say start from 0 to 2. So start from 0. Look, this -1, 2 means 0 somewhere here. Let's say 0 including to 2. So this for B is going to be 0 here, but it's including to 2 excluding. So look, this is 2, but excluding here. So where do they intersect? Means where do they have things in common? So they have things in common from here, look, all the way to here. Means they have common, because here there's nothing. Let me do this. It makes sense here. So this set here and this set here, where do they have things in common? Means in the intersection. They have intersection from here to there. So we're going to say, oh, we start from 2 But since this is including and this is excluding, I told you from previous video, means you want to say this must be excluding. So you say this excluding because one of them is excluding. It goes all the way to here. So this is including and this is on the line also. So both is say x include what? 0. So this is intersection of A, intersection B, and intersection means end. In other way, you know what I'm saying, means end. So here, if you look careful, we don't have anything they have in common. This goes from -2 all the way to the left, and this goes from 3 all the way to the right. So they don't have something common. They don't. It means they don't have where they intersect, where they have in common, like here, or anything they have in common. They don't have because this one goes to the left, this one goes to the right. So this is not true. So this is wrong. They don't have anything common. Like for example, this equation just gave to you. Now we go number 4. Okay. So number 4. Remember this is excluding. Okay. Let me explain to you something here. Look, if you say if something is not on, means it's off. If something is not off, means it's on. You know what I'm saying? So these people, they say we have it if, okay, x, okay, don't worry about this, okay. From -2 to 3, look, from -2, do you have any data? No, we don't have. So if we say -2 to 3 is not set of what they gave to us. So -2 is excluding, and then to 3 is including. So these, excuse me, these are not the element because they are not on set. Okay, just slow here. Means we know our stuff, there's nothing here. So from -2 to +3 including is not part of our element because there's nothing. So if I say this, means this is the part of our element which we're given. Do we have anything there? No. So you have to say this is not. You know what I'm saying? So this is what is not. This is not. So when you negate, means in other way, just a minute, sorry. Let me just check an equation. I feel like I copied wrong. Just a minute, you know what I'm saying? Sorry. Just a second, sorry, apology. Yeah, cool. So yes, look, means x is not, oh, I see. So if it's not excluding, means it's including. That's what they say here, is including. And if it's not including, means it's excluding. So it's true. So x is not the element of including, means it's not including, excluding. So it's true. And also this x is not between here. Is not including, means excluding, but and then there is no element here. That's why we negate. We say not element, because when you say this, means it's element. So we say not element of including, means we don't include here. Excuse me, one more time. If you look careful here, we say I hope some of them they catch, some of them didn't catch. Means if you look careful here, it's like it is excluding. No, is it? Excuse me. They say x is not element of including. It's true. Means this x is not including. That's why I say it's not element of including, because this is including. And here is not element of excluding, because this excluding is true, because it's element of including. So this is true. Now we go for the last one. For the last one, you see, the last one is same as this. What did they say? This with this, or this with that. So they kind of separate. They say, okay, x are element of all real number, but x is less than -2, is true, less than -2, or this means or x are element which are including 3 and more. We're done with the first question. Now let's come to the second question. This element of A, this element of B. So now we say find A union B. A union B means put them all together. You know what I'm saying? Put them together. So I'll say A union B. Let me just do it here, and then we're going to see which is the correct answer. So A union B, I'll do this. Put them together. 0. Now after 0 go 1, because you unite, you put them together. Then after that 2, and then 3, and there we go 4, and there we go 5 and 6. Oh, okay. So just one thing. Whenever you write in set form, please don't write as a notation. You know what I'm saying? Don't write as a notation. So of course this is not true first, and don't write as a notation. And apart from, look, these are integer. These are integer. You know integer? When you say 1.5 is not integer. Integer has to be 1, 2, like actual number. 3, 4, 5, -6, -8, like from 0 to whichever number, but it should not be like square root of 5, that integer. When you say 1/6 is not integer, it has to be like the whole number, like 1, 2, 3, 4, 5, 6, integer. You know what I'm saying? So now if you look careful, here I say x are element of integer. It's true because there's no fraction here. Look, everything is a pure number. And those numbers start from 0, yes, it start from 0. Including, means yes, including 0. All the way to, including 6, all the way to the last number, because you unite them. You know what I'm saying? So you don't write it as an integer, because you know why first you don't write like this? Look, when you say your number start from 0 to 6, oh, why you say that? Why this is the same as that? Somebody may say this is the same as that, because this is like saying you start with your number including 0 to including 6. But you know why I don't say this is correct? Because when you say 0 to 6, it could be 1.5 also. It could be any number. So when you say this, and when you look, means you tell them these are element of all integer. The Z represent the integer. And you can see all these numbers like a 0, 2, 4, 6, 1, 3, actual integer. You don't have a fraction here. You don't have a square root here. You know what I'm saying? Among these numbers. So this is correct, this is not correct, and this is not correct. You know what I'm saying? So we don't. So answer is C. Option 5 is option 3. And this one here, this is true, I say. This is not true. This was wrong here. You know what I'm saying? Okay. Now we go for the last one. For the last one, I'm gonna have to raise them on top. Just a minute. They might have asked us what is the intersection? Is A and B? Okay, it's not part of the question, but I just want to add it out for you as a kid. If they ask A intersection B, I could have said this is same as A. Okay, what are the number between where they have in common? This is common for both. Yeah, that's the only number, so it's only 2. That's a intersection B, or I could have written this as x are element of real number, but x is just equal to 2 because just only one number. You know what I'm saying? So I'm going to raise these and then we do the last question. Cool. Now we go, guys. My pouch off. Just so wet a little. Okay, now. So now let's look at this question here. See, which of the following is true? The LCM lowest common multiple of 8, 10, and 12 is 120. So we can just say, yeah, it is. You know what I'm saying? Now you need to check it and solve. So first and foremost, for you to do this, you need to know something called prime numbers. Prime number are 2, 3, 5. Let me write some. Prime number. You need to know this, brother and sister. Prime number. Prime number. These are numbers. They're only divisible by itself and 1. And these are 2, 3, 5, 7, 9, 11. No, 9 is not, because 9 can be divisible by 3. Only itself and 1. We go 11, we go 13, we go 17. We go 19, 21, no, because 21 can be divided by 3. You go 23, and then you go 29, and then you go 31, and then etc. etc. So these are some. So these are prime numbers. So now, for you to know LCM or GCF, you know, or HCF, you need to know the prime number. So what I'm going to do, I'll start with the first 10. So these are 8. So you have to divide by the first prime number and see if it's divisible by the first prime number. Can this be the first prime number? Oh yes, 2. How many 28? There are 4. So don't go to the next before you finish this again. Try again. Yes, can be divided by 2. And this can be equal to 2. Or we can divide again by 2, which is going to give us what? 1. Oh, so 80 meaning, okay, let's do the next one also. So if I say 8 equal to 2 times 2 times 2, or you can say this equal to 2 power 3 means 2, there are 3 of them. Okay, now we go for the second number. Second number is 10. We do the same game, 10, and also go 2, it's going to be 5, and then you cannot divide by 2. Can you divide by 3? No. You go, if you cannot go to the next 5, yes you can. 1. Oh, so if I write 10, I would say 10 equal to 2 times 5. Now you go for the last one. For the last one is 12. So say 12, you do the same game. 2 you get 6, and then 2 you get 3, and then you get 3 you get 1. Oh, so now 12 equal to 2 times 2 times 3. And this you can say equal to 2 power, there are 2 of them, times just only 1, 3. Okay, same here, there's only 2 power 1 and 5 power 1. So what you want to do, for LCM, you say LCM, what you do, you look all this group, okay, and then look the number with the highest degree. You know what I'm saying? But it should not be the same base. So for example here, look, our number is going to be 2 power 3. That's a number with the highest exponential. Excuse me, I was meant to say it. Number with the highest exponential here is 2. So so take that and then multiply. Come to the second group. The second group, look the number with the highest exponential. So 2 and 5. I'll take 5. So now the question is, how if I have a 2 power 2 and 5, for example here? You know, I could have taken 5 still. You know why? Because you don't take the number with the same base again. Even though this has a high exponential, but it could have the same base. This is the base, like the number at the bottom, like this. Base, and this is exponential. This is the base, this exponential. So don't take the number, even though this has the highest degree, but I couldn't have taken if it was 2 power 2. I wasn't going to take it because it's the same base as the top one. So by any means I'll go for this. So, but we're lucky here, just 2 power 1, 5 power 1. So of course I'll take this one. So you multiply that. Now you go for the last group. Am I going to take this or this? I'll take this. Even though this has a high base, but we don't take something with the same base. I mean, in other way, it has to be this different base. So I'll take this. So multiply by 3. So now 2 power 3 equal to 80 times by 5 times by 3. So this is going to give us 40 times 3 equal to 120. Oh, it's true. So this is true. Option A is true. Now you go to question 2. So HCF is very easy. HCF we use this because oh no, this other number. Okay, let me just show you something. It's not part of the question, but I want you to understand. For example here, if they could have asked us find HCF, but it's not part of the question. If they could have asked me to find HCF, you see how I did? Please do the same way. It's very easy. So what you do, look all the number which appear in all 3 groups. 2 appear here, here, and there. Okay. Now we come here. Now these 2 appear all the 3 groups? No, it only appear here and here. So we don't want to check it. You need a number appear all everywhere. Now this appear here, here, and there? No. So the only number appear like, oh, this group is only what? Is only 2. Okay, so HF could be only what? It could be only 2 for this case. That could be our HCF for this case. But unfortunately, they didn't ask us that question. But for the second question, they asked us to find a HCF of 18, 36, and 27. They asked if it's 3. So now let's take our number and do like how we did and see if our HCF is going to be there. So I'm going to raise this quickly. Now we go. So now we're going to take a number and we do the same thing. Get your prime number. So take 18, and the second one is what is 36, and the third one is what is 27. Let me go speed a little. Okay. So now we go. If you divide by 2, this is going to give you 9, means you put the prime number. Can you divide by 2 again? No. What is the next prime number? 3. Okay, this is divided by 3? Yes. How many 3, 9? There are 3. Now you look, can you divide again by the same prime number? Oh, yes. And this is going to give us 1. Oh, so if I have 18 is same as 8, 2, these are prime factors. 2 times 3 times 3, and then you write again here, okay? You simply say 2 times, how many 3? 3 there, 2. Now we go for the next one, which is 36. You do the same again. So now this is going to be, okay, by 2 is going to give us 18, and by 2 is going to give us 9, and by 3 is going to give us 3, means you put prime factor. 3 gives us 1. Oh, so if it's 18, equal to 2 times 2 times 3 times 3, and equal to 2, and then times 3, how many of them there? There are 2. Now we go for the last one, which is 27. So 27 is, okay, by 3 you get 9, and then by 3 you get 3, and then by 3 you get 1. Oh, so 27 is 3 times 3 times 3, and this is the 3 power cube. Okay, now we want to get HCF, highest common factor. HCF is highest common factor. So highest common factor, we say we look at number which appear in all 3 groups. Okay, now we go. Okay, 2 here appear, it must be go this way, like this way. 2 here appear, do you have any 2 here? No, so we cannot take this because you need number like top, bottom, and other way. Now we go 3. Here there's a 3. Do you have a 3 here? Yes. Oh, yes, we have. So this is going to be a common factor. Let's see if there's another one. Do you have another one? Let's go. Now we go this. Yes. Okay, so we have a common factor. The first 3, which is what? HCF equal to 3. Okay, and you have another 3? Yes, another. Multiplied by 3. Don't take 3, 3, 3. No, only if it appear everywhere, right? Only one of them. If you everywhere, write another one. So this is going to give us high common factor equal to 9. Our highest common factor of these number, which is 18, 36, and 27, is what is 9. Now I'm saying, now we go for C. So this is not true. They say 3 is not true. It's 9. Our highest common factor is what is 9. Okay? Excuse me. Now we go for the next question. For the next question now, okay, for the next question, highest common factor equal to 9. Excuse me, taking my, okay, now for the next one, let's see the prime factor of 18 and 2. The prime factor of 18 and 2, very, very easy. So it's okay, 18 and 2, 18 and 2. Excuse me, I'll write my 2 here. Okay, so we do like how we did here, okay. What is the prime factor here? It's 2, we get 9. This 3, you get what? You get 3, and 3 you get what? You get 1. Now here, prime factor is only 2. We don't have another. You give us 1. So for 18, the prime factor of 18 is 2 times 3 times 3. Now we can say 2 times 3 squared. So these are prime factor like these. These are prime factor. Means the factor that you use here are prime number, which I just show you. I'll show you before those numbers which are wrote over there. Okay, now we go for 2. So for 2, only 1 prime factors. So what is a prime factor? A prime factor here is 2, here is 2, and 3. Those factors, the number that we use. You see we have used 2, 3, 3, 3. So our prime factor are 2 and 3. The line of these people is not 9. This is not true. You know what I'm saying? So the prime factor for this case is not 9. It's not true. You know what I'm saying? So now this is not true. So for question number 6 is option 1. So look, man, first time on my channel, make sure you click subscribe over there. You know what I'm saying? And you can watch our music if you're first time. And please don't forget to subscribe to my music channel. You know what I'm saying? And I appreciate your support. Peace and love. I'm out.